Hi guys, welcome back. So this is the second session, and in my last video, I was talking about what is modulus and how does the modulus look like, and basically we talked about the number system. It's a very basic in relation to the modulus of a function, and we we also talked about how to expand the expression of the modulus. But let me brief it out here. Like we defined a variable x, basically, and this two vertical bars we denoted that this is the modulus, and we defined like when it is x when x greater than equal to 0, and it is minus x when x is less than 0. So basically this is the definition of modulus, definition of modulus. So the intention of the class is to dig a little deeper in this aspect, like how well we can associate this particular understanding, basically. So as you see, this particular x is greater than equal to 0 and x less than equal to 0 is basically what we call it. So basically this x greater than equal to 0 or x is less than 0, or x less than equal to a, x greater than equal to a. See, basically in mathematical terms we all we call these expressions as inequalities. So this is also a different concept altogether. So we understand that we understand this. So basically, what I wanted to speak is, let me just erase this out. Hmm. So, so modulus of x is x when x greater than equal to 0, and minus x when x is less than 0. So basically x is greater than equal to 0. So I talked about the line number system also. Basically, we represent all these numbers on an imaginary line. So basically, let's say we draw an imaginary line like this. Sorry. So we draw an imaginary line like this and put two arrows into to both of its ends, so that this is a continued line, and we marked 0 somewhere here, and we marked the equidistant portions of a unit distance, so 1, 2, 3, and until plus infinity, and -1, -2, and -3 until minus infinity. So x greater than 0. So this is basically two things: x greater than 0 and x equal to 0. So in equality, when we can come to that topic also, but we understand, I understand that you understand this. So when x is equal to 0, so it means that we are considering this point. So what we do, we just we just put dot here, a more darker spot, in order to recognize that this is included. Okay. And greater than 0 means like everything which comes in this side of the number system. So we basically do like this, or probably you can shade it like this also. So x greater than equal to 0 is all the numbers lying towards right of this origin, or you can call it as 0, including this 0. Okay. And x is less than 0 means this is something, this area, and which does not include 0. Okay. So here it will the numbers are x greater than equal to 0 means The numbers are 0, 1, 2, 3, 4, 4.5, 5, 5.5, infinity. And less than 0 means like uh, minus infinity, dot dot dot, minus 3, minus 2, minus 1, minus 0.5, and then 0. Okay, so all these numbers come over here. So okay, so we understand these things. So now coming on to our main association, like, so this is an this is a simple definition of the modulus, but how we can associate this understanding with graphical representation. So I hope, let me define a few concepts of graph over here so that you guys understand the basic things. So basically, graph is just plotting some numbers and just joining them in a plane, basically. So in how basically in mathematics we basically draw two vertical lines like this, and the two vertical lines making 90 degrees to each other. Okay, this is 90 degrees, and this point is basically an origin. Okay, it's still 0. Origin is always 0. So this right side, it's a positive x, this is negative x, this plus y, this is minus y. Okay, tends towards infinity. Okay, always remember this. So this is a pictorial representation to associate this understanding with this. This is a generic concept. Okay, always remember this is equally applicable everywhere in the mathematics. So basically this area, so this plane, okay, this plane, okay, this plane, the upper portion is always positive. Okay, this area, and lower than this horizontal line is always negative. Okay, is always negative. Okay, we understand this. So basically, for an example, so these two vertical lines are there. Okay, this is origin, this is x, this is y, this is minus y, this is minus x. So this area is positive, this area is positive. So this area, this shaded area, right, this area, this is always positive plus positive. This is positive, this is negative, this is negative positive. Always remember x always comes first and then y. Okay, so x comma y always this. So here minus minus, and this is plus minus, so plus, and this is minus. Okay, so this is a really important point to understand. Now coming on to the next thing, like for an example, okay, again two vertical lines. Okay, so for an example, this is 1, this is minus 1, this is minus 2, this is 2, this is 1, this is 2, this is minus 1, this is minus 2. Okay, so you are here, you move, let's say for an example, from one place to this, you cover one unit distance. Okay, and from this position you come upwards. Okay, and you come here. Okay, so from here to here you came. Okay, here your position was 0 0, because in this position x is also 0 and y is also 0. Here x is 1, but y is 0 because we have not covered any vertical distance, right? You are always going horizontally. Now you move upwards, so basically you are covering x also and you have covered y also. So here this point becomes 1, 1. Okay. So in the similar way you can arrive this point also. This is your 2, 2. So in the similar fashion, this point minus 1, 1. This point minus 2, 2. So on and so forth. So you can consider these points also. Now, this is something really crucial to understand. Now, let us plot this. Let us plot this. When we understand that, let us plot this. So again, two vertical lines. Okay. Two vertical lines. This is 0. Okay. Now, I told you in my previous class that x can assume any values. Okay. So for this area, x greater than 0, so this area, we are considering this area, this portion of the line. So for any value starting from 0 until infinity, this area of x is positive, and basically for an example, like this is modulus of x. Okay, for an example, let us understand this as an equation. Y is equal to modulus of x. Okay, so we are trying to plot this. Okay, so this modulus of x can then be associated with this definition. So here we are getting couple of things. This modulus of x is y. So y is equal to x when x is greater than equal to 0. Y is equal to minus x when x is less than 0, where y is equal to modulus of x. Okay. So basically, so in this case, when y is equal to x, x greater than equal to 0. So when x is 0, y is 0. When x is 1, y is also 1. Okay, so we come here. When x is 2, y is also 2. So we come here. Okay. So on and so forth. So it is going to be like this is 3. So we will come here. So basically what we will do, we are going to join this. Okay. So I will join this. Okay. These lines, these two lines, I joined this. So this is your y is equal to x. Okay. Now what about y is equal to minus x? So when x is equal to minus 1, y is equal to 1. Because x is equal to minus 1, then y is equal to 1. Minus 1 minus into minus 1 means it's equal to 1. I told you like last time, right? So you come here. Then minus 2 will come again positive y. So basically you are okay. So this modulus of x, you see how we drew this as a graphical representation? Isn't it fascinating? So one equation turns into a graphical representation. So it's really interesting. So this is the graph of a modulus function. modulus of x. This is the graph. It is always positive. I told you, right? This area is always positive. It is always positive. So friends, like, if you associate with this basic understanding, right, things will be very easier and smoother. So this is the small video which I wanted to share with you. We will elaborate it more in our next video, where I would be solving some inequalities and define some basic principles of inequalities. So we'll do some reverse engineering. Okay, so by understanding and looking at this, I think things would be more precise now and more in understandable format. Till our next video, thank you, and a very good day ahead. Thank you so much. Bye.